So I want to get my lowest value, which happens to be my pink, and it starts at 4. And I want to go up to my highest value, which happens to stop at 5. Now, if I look at these endpoints, my lowest intersects the point that's solid and filled in, and my highest intersects a point that's solid and filled in. So this means I'm going to also have square braces for my range. Okay, what questions do you guys have about that process?
Can you repeat how you know you get square or
Yes.
parentheses?
Yes. So I'm going to write it up here. So a square bracket will be a solid filled in line. Okay. An open will be if you have an open circle, so that'll be round if it's open circle. Also, if you have arrows going to infinity, you'll have the round bracket. So I guess that should go there. So you could have those two possibilities. And what else? I think that's it.
Okay.
Okay, these are closed / included. These are open / excluded. Okay. All right, so I want to make sure I at least get number 2 in there with you guys, because number 2 is a little different than number 1. So in number 2, we've got arrows. These arrows mean that at some point in my function, I'm going to infinity. And so either in the domain or the range, or maybe both. And so I need to be really careful about how I use my sticky note. Let's start with domain. So I'm going to start on my left and my right. And I'm trying to get as close as possible to my function. Now, some people might do it like this and be like, hey, that works. But these are arrows, which means this function is going to keep going up in this direction, which means that if I put my sticky note this close, I'm covering up part of the graph up here. It just happens to be part of the graph that I can't see. So in reality, I have to keep moving my green card back and back and back and back and back, because we imagine my green card extends all the way up to infinity. But no matter how far back I move it, I'm always going to catch up with my function. So I can't have a green card on the left. So I'm just going to throw it away. Now on the right-hand side, I have the same issue. I could try to get this close, but my arrow is telling me that I'm eventually going to hit my green card. So I try to move it back and back and back and back. But if I imagine that this green card extends forever, my arrow is telling me that I eventually am going to hit it. So I can't have a green card on the right either. This means that my function can go all the way left and all the way right. So what symbol represents being able to go all the way to the left and all the way to the right? Anybody?
Is it infinity or?
Yeah, it's the infinities. So all the way to the left means I can reach negative infinity. All the way to the right means I reach positive infinity. And remember that you always use round brackets when you have the infinity. Questions about that domain? Okay, so arrows indicate we can go all the way to the left, all the way to the right. And so our domain has to be from negative infinity to positive infinity. Okay, so now I'm going to work on my range, which is a little bit more straightforward to see because my arrows are like mostly pointing up. So for my range, I can cut off part of the grid on the bottom. I can get all the way up to here. These arrows that are at the top aren't going to swoop down and come down here at all. The function stops right here. So this is the lowest my function can go. But can I put my orange card up here?
No.
No, because very clearly my arrows will hit it no matter what. Okay, so my upper limit at the top, we know is going to be infinity. And my lower limit at the bottom, this vertex is at -2. Okay? Because this function is solid right here, it has no open circle, I'm using a square bracket because -2 is defined on that. So what questions do you guys have about number 2? No questions on number 1 or 2?
Yeah, I have a question.
All right, what's up?
So, like for number 2, for the domain, it wouldn't matter the coordinates like how it did on the first one, right? Because it has like infinity.
Yeah, because it's got arrows, right?
Okay.
These arrows go on forever. But here it had dots. And
Okay.
so those dots matter.
Okay.
Good question. Okay, which looks harder, 3 or 4? We'll go through one more.
4.
Okay, so we'll do 4. So first we'll start with domain, our green cards. I can get all the way to here, right? And cut that much of the grid off. And I don't have to worry about there's no arrows down here. I know that I can cut it off right here. Okay. Now on the right-hand side, can I put a green card here?
No.
No, because clearly my arrows are going to hit it no matter how far back I put my green card. Okay, so my domain, this is at -2. It's very hard to see, but that's a -2. And again, this is on the function. There's no open dot right here, no break in the graph. So because we have a solid line right there, we're defined on the function. So we're going to have a square bracket. So that's the farthest left it can go. And now the farthest right it can go is going to be to infinity. And we always use a round bracket. Now for my red cards, could I put my red card here? Anybody?
No,
Why?
because the arrow's going to run into it.
Right. And if I lower it, what's going to happen?
It's still gonna run into it.
Exactly. Is the same thing going to happen on the top?
Yeah.
Yeah.
Yeah. So what should my range be?
Positive infinity?
Positive infinity is my upper limit. What's my lower limit?
-infinity.
Perfect. Job. All right, and that is number 4. I put the solutions to this whole sheet. There's 4 more problems on the back on Canvas, so you can go ahead and try them yourself and then check Canvas for the solutions to make sure you're understanding. Questions before you guys head out? Okay, if there are no questions, you guys are free to go. You guys did a great job in class today, so good work and keep it up.
Bye.
All right, bye.
Bye.